everyone, I am going to make a video for page 17. The title of the page is Mixed Up Examples. So what this page is a series of problems, hypothesis tests, except number 5. Number 5 is a type 1 and type 2 error question. And each one does not tell you what kind of test it is. It's just written in context, okay? So my goal is to read through the problems with you, and I'm going to point out some of the really important information as I go, okay? So, table's dirty, sorry, let's get started. I'm only going to do numbers 1 through 4 because number 5 is a type 1 and 2 error problem. And these are just extra practice, and so I don't have room to do them in the packet. However, some of them actually repeat, so you would have the opportunity to redo them in the Unit 3 review, which has other questions as well. So don't worry, it's not just repeated questions. Okay, so let's get started. Mixed up examples number 1. It says, suppose the CEO claims 80% of the company's 1 million customers are very satisfied. So right away, we're given a percentage, okay? That's important. So while it's not written, in percent form, it is a percent there of 1 million customers. And then it says to test the claim, the local newspaper surveyed 100 customers using simple random sampling. So this is who they surveyed right there. That's your N, okay? Why did they give me 1 million? That's my population size, okay? So I get the 1 million just so that I can check my conditions if required, which would say they are met, right? The 100 is less than 10% of 1 million. Okay, now we keep reading. The result, 73% are very satisfied. So that's the result of this survey. So in that part, they just gave us P hat, okay? And then it says, based on these results, should we accept or reject the CEO's hypothesis? So now we have to go back and read. It just says the CEO claims 80% are satisfied. And then it says, should we accept or reject the CEO's hypothesis? Okay, so if I look at that and they just say 80% are satisfied, then when I take out my paper to record everything that I need for this problem, so this is page 17, number 1, think about this. Accept or reject the CEO's hypothesis. So they say it's equal, and we're accepting or rejecting. So really, we're going to have to show not equal to, regardless of whether you've identified the type of test. That's based on the wording that's provided here. Okay, now, 2 percentages were given, one from the population and one from the sample. So this is a 1 prop Z test. I know you just heard me say there were 2 percentages given, so let me clarify why it's a 1 prop Z test. One of the percentages is from the population. P naught is from the population. That is the 80%. The other percentage is from the sample. That's P hat, 73%. If this were a 2 sample test, I would need to have information from 2 different groups, and there are not groups here. It's population versus sample. So I want to make that clear. Now, to go to our calculator, we need P naught, we need X, and we need N, okay? N is 100. We surveyed 100 customers. And if we know that 73% of those 100 customers were very satisfied, then we can do this math to find the X value we need. Okay, so in our 1 prop Z test, I'll record everything again over here. P naught is going to be the 0.8 that we believe is the current percentage of satisfied customers. X is the 73 who said yes. N is the 100 we surveyed. And our alternative hypothesis is not equal to because no direction is provided in the problem. So before we actually run the test and get the results, we should record our null and alternative hypotheses. So I believe the current percent is 80, and then I'm going to test that it is not equal to 80. Now we get out our calculator, okay, and we run a 1 prop Z test. So we go to stat, arrow left to tests, and this is number 5. Okay, P naught, I'm going to fill this information in, is 0.8. X is 73, and N is 100. And then I want to select not equal to and go down to calculate. Z is negative 1.75, and my p-value is 0.0801. So let me record that information. Z equals negative 1.75, and my p-value is 0.0801. So finally, we need to make a conclusion. So we need to compare the p-value to the provided alpha level. It says here in the last sentence, assume a significance level of 0.05. So that means we are comparing 0.0801 to 0.05, and it is in fact greater. If the p-value is larger than the alpha level, we fail to reject the null. If that happens, then we failed our experiment, which means we don't have the evidence to show a change. So there is not enough evidence to show the proportion of people satisfied is different from 80%. Okay? Not too bad. Okay, let's move on to the second question. We've only got 3 more now, so we've got to read through these carefully. So I'm going to move my solution over to the side so I can read this question. I'll bring it back over, okay? I'm going to shift this up so I have a little bit more room. Okay, ew, guys, my bad. Had my niece and nephews over last weekend for Easter, so something sticky is underneath of here. Fantastic. All right, let's read number 2. The Acme company developed a new battery. The engineer in charge claims that the new battery will operate longer than the old. To test the claim, the company selects a simple random sample of 100 new batteries and 100 old batteries. Okay, that's 2 groups. Now, this is either going to be a 2-prop z-test or a 2-sample t-test based on what we've learned so far. So let's keep reading. The old batteries run continuously for 190 minutes with a standard deviation of 20 minutes. The new batteries run for 200 minutes with a standard deviation of 40 minutes. So we were just given, although it's not as clear as I would like it to be, one mean for the first sample and a standard deviation for the first sample, as well as a mean for the second sample and a standard deviation for the second sample, right there in those 2 sentences. Okay, so if they provide me with 2 means and 2 standard deviations, then this is going to be a 2-sample t-test. And I don't have 2 lists here, so this will be on stats, which means we will need to do some recording here because we are going to have a significant amount of information to enter into the calculator. Now, let's just make sure that we understand the question. Test the engineer's claim that the new batteries run longer than the old. Okay, so we want the new to run longer than the old using a 0.05 level of significance. All right, so for this question, I'm going to actually fold this piece of paper so that everybody can see very clearly what I'm recording from the paragraph, and then I can use the packet if I need to. Okay, so for number 2, first of all, this is going to be a 2-sample t-test, and we're going to use stats. So I'm just going to make a running list of what I will need to enter into the calculator. If I wasn't actually sure, right, this is the point where you just go to your calculator and go to the 2-sample t-test and make sure you know what you need from the paragraph. So I'm going to need to make sure I identify who group 1 is and who group 2 is. And from each group, I'm going to need the mean, the standard deviation, and the sample size. So I'm going to write those out, the standard deviation from group 2 and the sample size from group 2. And once I have all of this, I'll write my hypotheses and we can run our test. Okay? Now, First group mentioned is the new batteries, okay? So we're going to make these new, and we're going to make group 2 old, okay? That means that when I go down here, I just need to be careful about what I'm entering where. So it says there were 100 new and 100 old. So there were 100 new and 100 old batteries. That's our sample size for each. And then it starts talking about the old. So let's go make sure we're putting that here. They have a continuous running that's supposed to be their mean. So it's 190 and a standard deviation of 20. Then it says the new batteries run for 200 with a standard deviation of 40. Okay? All this is now filled out, and we want the new to run longer than the old. So we want group 1 to be greater than group 2. So when I go over here to write my hypotheses, remember that this is a 2-sample t-test, so we assume that the means or mu's from groups 1 and 2 are equal, and then we want group 1 or new to run longer than the old. So we want the mean from group 1 to be larger than the mean from group 2. So we will end up with a t and a p-value. Let's run the test so we can record what we see. So let me go to my calculator. I'm going to go ahead to stat, arrow left. This is a 2-sample t-test, that's number 4. And it's on stats. So I'm going to go ahead and enter. Make sure that if you're on data, change it to stats. We're going to do 200 for group 1 is the mean, 40 is the standard deviation, and 100 is the sample size. And then I'm on to group 2, 190, 20, and 100 again. And I actually want group 1 to be bigger than group 2, so that's my last choice. We always say no to pooled, and we hit calculate. So I'm going to record my t. It's 2.2361, and my p-value is 0.0134. Okay, so go ahead and take a look if you need to at my calculator. I'll get that out of the way so we can make our conclusion. Again, here alpha was 0.05 if you go back and read the problem. So I'm at this step where I compare my p-value to my alpha level. So 0.05, and my p-value is 0.0134. It's now less than alpha, which means we get to reject the null. Okay? If we do that, then we do have evidence. Our experiment was successful. So there is evidence. There's enough evidence to show the new batteries run longer than the old. I could even say the mean for group 1 is bigger than group 2. I'm just showing the change, and I'm using this wording right here, run longer than the old, okay? All right, excellent. So 2 out of 4 tests done. Let's see what example 3 holds. Okay, I'm gonna move on here. Great, gross. Okay, I won't move this anymore, I'll just add paper. Example 3. So this one says, oh, Acme makes everything. This is now the Acme Drug Company developing a new drug, and it's designed to prevent colds. They say it's equally effective for men and women. To test the claim, they choose a simple random sample of 100 women and 200 men. Okay, again, we've got 2 groups. Now we're looking to determine whether we have means or proportions given. And good, they give us our population size to make sure that we understand that our conditions are met. At the end of the study, 38% of the women and 51% of the men caught a cold. Guys, I was just given 1 percentage from each sample. This means that this is a 2 prop Z test, okay? Based on these findings, can we reject the company's claim that the drug is equally effective? Okay, so we're rejecting whether it's equally effective, which means, again, in that wording, there's no specific direction provided, but in example 3, I now know that I'm going to be testing not equal to, because it says reject that it's equally effective. And the opposite of that is that it's not equal. So we now need to record that we have group 1 and group 2 here. Oh, oops, let me write the kind of test. I'm sorry, guys. Let me write that over here. This is a 2-prop, z-test. Go ahead and put that on silent for me. Just kidding, it's my own. All right, the first group mentioned is the women. The second group mentioned is the men. So remember, you can always go to your calculator if you forget what we need to run a 2-prop z-test. But just as a reminder, we need X1 and N1 from each group. So the number of people who said yes and the number of people questioned. And I'm leaving room because this is a percentage, so we're going to need to estimate, okay? And use the sample size to help. So over here, we'll need the number of people who said yes and the total number of people sampled from the men. So we had 100 women, that was group 1, and 200 men was group 2. It said 38% of the women, so that means that we're going to have to take 0.38 and multiply it by 100. So our X1 will be 38. And 51% of the men, so we're going to have to take the 51% and multiply it by the number of men. Check, be careful, that was actually 200. So X2, if I multiply these two numbers, that's 102 men, or 51% of 200, okay? Now I can write out my hypotheses. We believe, this company, the CEO believes that the proportions are identical for men and for women. And we are testing whether or not there has been some kind of a change or that they're not equal to. So let's go to our calculator and run a 2-prop z-test on this information. So let me go ahead and turn this thing on. Stat, arrow left to test. A 2-prop z-test is number 6. I'm going to enter this information. That's 38, 100, 102, and 200. And I want to select not equal to for this test and go down to calculate. So I will record that I have a z of negative 2.1276, and I have a p-value of 0.0334. Okay, let me get my calculator out of the way so I can make a conclusion. I want to compare this p-value to an alpha level of 0.05, and my p-value is again less than my alpha level, so we can reject the null. Okay? All right, so what kind of conclusion do we get to make? Now, we're going to reject the company's claim that the drug is equally effective. Okay? So we found that the drug is in fact not equally effective. So there's evidence to show the drug is not equally effective for men and women. Remember, we are showing the alternative here. So we're showing that in fact that it was not the same. Okay, one left. Let's see what we've got. I'm going to go ahead and fold this to start because I know I'm going to want to get that out of the way so we can see everything. All right, guys, I'm already looking at number 4 and seeing a list, okay? So that means we're going to need to put this information into list 1, which I actually have already done. So if you need to pause the video at this point to do that, go ahead and do that. But I'm going to continue to read the problem. If I'm given a list, right, and it's just one list, then I'm running a t-test for sure. And that t-test is going to be on data. So the only other thing that you're going to find in this paragraph is a hypothesized value. So let's go ahead and read it. It says this list is this year's water pollution readings at State Park Beach, and they seem to be lower than last year. We have a sample of 10 readings, so that's our sample size, and then they list the readings. Does the sample provide sufficient evidence at the 0.05 level to conclude the mean of this year's pollution readings is significantly lower, well, there's my direction, than last year's mean of 3.8, and there's my hypothesized value, or mu naught. So I'm going to go to my paper and write down what I know about this question. This is a t-test on data, so we put it into list 1, okay? And the only other thing we need to give the calculator, besides the direction, is the mu naught mentioned, which was last year's reading of 3.8. This is a nice one where, since we're entering data, and I already did that, we can write our hypotheses right now. So we think the mean is 3.8, and we believe, or sorry, the old mean was 3.8, but we think it has now gone significantly lower and is less than 3.8. So we're going to go ahead and run a t-test, and we'll get a t and a p-value and be able to make that conclusion. Okay? So I'm going to take my calculator. Remember, I put the data in list 1, so I'm going to go to Stat, arrow left to Test, and select option 2. This is a test on data. The mean, or mu naught, is 3.8. My data is, in fact, in list 1. Always leave frequency at 1. And we believe that the mean has gone down or decreased. So let's go ahead and calculate. Oh, wow. This is a very large negative t, right? So we've got a negative 4.7492. That's off the charts. It's more than 4 standard deviations below the mean. And look, we've got scientific notation here. 5 times 10 to the negative 4. So I can also write that as 0.0005, whichever you would prefer. So let me get this out of the way. It's time to make a conclusion. And I'm doing a lot of rejecting today. So we're going to reject this again at the 0.05 level. Oh, there go my dogs. I stuck them outside on such a nice day. And they are just loud. Okay, my alpha level was 0.05, and my p-value was 0.0005. So my p-value is less than my alpha level, and we get to reject the null. Again, that means there is evidence. And then I like this question because it's nice to rephrase that to show the mean pollution reading has decreased, right? That's really what we showed. But if you like to repeat the wording, you can even rewrite this to conclude the mean of this year's pollution readings is significantly lower than last year's mean. Okay? I believe in you in terms of being able to assess number 5. This is a type 1 and type 2 error question, and I think that you guys will do well with that. I will not only post this video, of course, I've already done that, but right underneath of it, you can find my handwritten solutions, which I will post, okay? So I'll post all of this, I'll scan that, as well as a PDF of solutions that I've created in the past, okay? Enjoy, hopefully this is helpful.